going over our warm-up for today, going back to just solving some inequalities. There's only one variable, so we're not actually graphing these on a coordinate plane. So we're solving for x in the first one. So hopefully you subtracted 10. So it would have been 3x is less than or equal to -3. Dividing by 3, x is now less than or equal to -1. It didn't ask us to graph it. If we had been asked, remember the difference between an open and a closed circle. This one is a closed circle because of the equal sign, and then you'd be shading to the left for less than. Number 2, that 5, this is a problem I've seen us get confused on before. That 5 is positive, so to cancel it out, this is the one where you do have to subtract it. So if -2x is greater than 2, x is still not by itself, so we need to divide both sides by -2. Well, warning bells should be going off in your head, going ding, 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 because since we divided by a negative, our inequality sign has to flip, making that x is less than -1 now. Again, if we were to graph this, since it's just less than, it would be an open circle, and once again shaded to the left. Today we're moving on to Module 8. We're only going to be doing 2 sections in Module 8, 8.1 and 8.2. 8.1 is all about correlation. And correlation, we're looking for a relationship. So we're going to be graphing data. They're calling it bivariate data. That simply means it's data that involves 2 variables. We've already graphed with 2 variables, so we're doing the same thing here. One way to show this data is with a scatter plot, and that allows us to see what kind of a relationship occurs between the 2 variables. And we say there's a correlation if you can link their values, as shown below. In the first one, because the general trend of the dots is going up, we say that it's a positive. Now keep in mind, not every single dot will follow that pattern. You're looking for the overall impact. On the second one, this time, overall they're going down, which means negative. Negative means that one of them is increasing and the other one is decreasing. No correlation is it's a typical scatter plot because the points are all scattered. There's no relationship between the 2 variables. Our first problem here shows the number of species of mammals on the International Union for the Conservation of Nature's Red List of endangered species. So we're going to take this data and create a scatter plot. So we're just taking them like ordered pairs and plotting them on the graph, and they did the 2004 352 one for us. So go ahead and finish the scatter plot. Adding the rest of the points to it. And again, you are going to be estimating here. Whoops, put that one in the wrong spot. Now the question says to look at the points that we just plotted, and they want to know what type of correlation has happened over the years, positive, negative, or none. They want to see if there's a trend and is the number of endangered species increasing or decreasing. So go ahead and talk over these 3 questions with your group members and come up with a consensus before you unpause this. Since the dots pretty much go straight across, there is no correlation. The number is not increasing or decreasing. And the trend since 2008 is for the number to remain around 450. Scatterplots is all about visualizing the type of correlation. Again, the 3 types, positive, negative, or no correlation. So if we look at the correlation illustrated below, which says TV watching and test scores. So the overall is as the number of TV hours spent watching TV increases, because it's going to the right on the x-axis, test scores decrease, which is your y. You can see the dots going down. There is a pretty high negative correlation based on this scatter plot between the 2 data variables. So question 2 says, based on that, what would you expect to be true of a person from this survey who watches very few hours of TV? And is it possible for that person to still have low test scores? So come up with a conclusion in your groups and then unpause. The expectation based on the scatter plot is that the person who watches very few hours of TV would have high scores. Is it possible for them to have low test scores? It is. Maybe they have another hobby besides watching TV that means they still don't study. Maybe they're, never at home for whatever reason. So it is still possible for them to have low scores. But overall, we would assume they would have high test scores. Now it's your turn to describe the correlation illustrated by the scatter plot with the snowboard competition. So describe if it's positive, negative, or none, and then include a description of what that correlation means based on this problem. This has a positive correlation. Overall, the dots are going up to the right. And the description would be the number of participants is increasing over time. So snowboarding, based on this, seems to be becoming more popular. Next, we're going to talk about correlation coefficients. Correlation coefficient is represented by the letter R, and the values range between -1 and 1. There are specific ways to find this. We're starting with just looking at the overall and predicting whether it would be closer to -1, 0, or +1. To be close to a -1, it would have to be a strong negative correlation, which is what they're showing you in this first box here. Pretty much all the dots are going down, so it would be strong. Between 0 and -1, the closer to 0 would be what we call a weak negative correlation, because overall you can see the points are going down, but it's much more gradual, and there's a section here where it's almost like it goes straight across. A strong positive correlation means that your R value would be close to a +1, because the dots here are obviously going up. And then we have the weak positive correlation, which would be between 0 and 1. And that means that overall the dots are going up, but it's not as tight, it's not as obvious as when it's a strong relationship. If there is no correlation between the two variables, then the points would be scattered all around, and we would say R is close to 0. So no correlation would be pretty much right at 0. Here in example 2, they've walked us through a table listing latitude and average annual temperature. They want us to describe the correlation and then estimate the correlation coefficient. And again, that coefficient is that R value, which is between -1 and +1. -1 if it's going to have a strong negative correlation, +1 if it's a strong positive correlation, and 0 in between if it's no correlation. So they have their categories. They then created a table, a scatter plot. So here's your latitude and your average annual. So then we first describe the correlation. We know that it's going down. You can see the dots overall decreasing. It's pretty strong. For the most part, there's none that's like going up or staying straight across. They're all a little bit lower than each other. So that would be a strong negative correlation, which means our correlation coefficient would be close to -1. Now they want you to go back and look at the scatter plot that was titled the snowboarding competition, which was under the year turn on page 249. And they want to know, is the correlation coefficient for the data closer to 0, no correlation, 1, positive correlation, or -1, negative correlation, and to explain. So go ahead, flip back to that page and answer the question. Since the snowboarding data, the points were going up one after the other, it would be closer to 1. The data shows a strong positive correlation. The last thing we're going to look at here is distinguishing causation from correlation. So a common error is when we interpret paired data as being confused between correlation and causation. If correlation exists, that means there's a relationship between the two of them. It does not necessarily mean that one variable causes the other. When one variable increases, the other one may increase or decrease as a result of other reasons behind. And we call those variables lurking variables, or sometimes I've seen them called hidden variables as well. So in example 3, we're deciding whether that correlation is a result of causation. Do the variables actually cause each other to increase or decrease? So the first thing is take a moment to read the article. Now that you've read it, step 1 is to identify the two variables, which is the size of the amygdala and the size of your social network. Step 2 is to determine the correlation. They're saying that the larger the amygdala, and I could be pronouncing that wrong, so bear with me, corresponds to larger social network, so that's positive. Now the question is whether or not that's a result of causation. Overall, they do say that it is possible, but it's unknown if which variable causes the other. Having a larger brain amygdala is going to make somebody more social, which means they tend to have a larger social network. Or it could be the opposite. If that relates to them being a social person and they already have a social network, it could cause it to grow as well. Looking at the question they want you to answer, says that a survey found that students who spent more time doing algebra homework also spent more time doing biology homework. And first they want us to identify the two variables. So identify the two variables and then indicate whether or not that's a positive or negative correlation, and then we'll be discussing whether or not that's a result of causation. Your variables here are the time spent on algebra homework and biology homework. And time spent on biology homework. So if you have Miss Furley and me, and she's a lot of your biology teacher, that means you better be spending lots of time on both of our homeworks. Because they're saying that they spend more time doing algebra and more time doing biology, that would be positive. So now the last question is it positive because algebra homework causes you to spend more time on biology homework or vice versa? And really and truly, neither subject is going to cause you to spend more time on the other. It could just be that you spend time doing homework anyway, or you need help on these two classes so you spend more time, but they are probably unrelated, meaning there is no causation.